Hello friends, welcome to the session of Quality of India. Myself R.N. Vishwakarma, and in this session we are going to explore 8 big losses in total productive maintenance. So before understanding 8 big losses in TPM, let's explore little bit about TPM first. So TPM, which stands for Total Productive Maintenance, it's a very important philosophy and which focuses on zero bad. We call it zero bad, B-A-D. Okay, so B stands for breakdown. So here we focus on reduction in breakdown or ideally making it to zero. So zero breakdown, then A would be for accidents. So zero accidents, and third would be defects. Okay, so no defects during processing, no quality defect, no rework ideally, no accident, no incidences, nothing. Okay, and no breakdown of any equipment or any facility or resources. Okay, so zero bad is the focus in TPM. So talking about TPM, we have 8 pillars. We can see the first pillar talks about autonomous maintenance, which is also called self-maintenance, and in Japanese this is called Jitsu Hosen. We call it JH in short, JH pillar, very popularly known. Second pillar is Kobetsu Kaizen. In short, this is also called KK, Kobetsu Kaizen. In English, we can call it focused improvement. So the focus over here is identification and elimination of losses. Okay, various kinds of losses are there, and we are going to talk about 8 losses in this program. Okay, so the losses we are going to identify and focus on improvement. So the focus of Kaizen over here would be on the losses only. Third is plant maintenance. Fourth pillar is quality maintenance, and fifth pillar is education and training. This is the fifth pillar, and sixth pillar talks about initial flow control, and seventh pillar talks about office TPM. So not only TPM needs to be implemented in the production floor, but this is also applicable for office TPM. And finally, the 8th pillar talks about safety, health and environment. So we are not only talking about product quality, we are not only talking about equipment breakdown, elimination of that. Okay, it is also focusing on safety, health and environment. So it's a very comprehensive model, total productive maintenance. Now let's move ahead and explore our understanding on 8 big losses. Okay, so when we talk about 8 big losses, these losses are very useful for improving overall equipment effectiveness. So overall equipment effectiveness is a very important matrix used in industry, and this is multiplication of 3 factors. The first factor is availability, second is performance, and third is quality. So when we talk about equipment, for example, let's assume there is a vertical machining center, VMC. So this can be used for any kind of equipment. I am taking one example. It could be a stamping machine, forging machine or anything. So let's assume there is a VMC, vertical machining center. Now I need to calculate availability. Maybe if I am calculating on a shift basis or on a daily basis, let's assume on a daily basis. So one day, whatever is the available time, I need to calculate what is the performance during that day, what is the quality performance during that day, and each of these elements would be in percentage. So multiplication of these 3 factors is going to give me overall equipment effectiveness. So it's a very important matrix for improving business performance, and there are detailed formulas and the way how to calculate them. So we are not going to explore right now about OE. We are going to understand the 8 big losses. So when we talk about these losses, so over here we can see there are 7 big losses, and these big losses are basically playing critical role in impacting the various elements of equipment. So once we start working on all these losses, our overall equipment effectiveness is also going to improve. So that's what the relationship. Okay, so you should be connecting the dots, that is understanding the losses, and you should be also understanding where this is exactly going to impact in your business performance. So overall equipment effectiveness in most of the organization we calculate it as a performance matrix. So this is going to heavily impact OEE improvement and your business performance as well. Now let's move ahead and explore these losses one by one. And the first loss we are going to talk is equipment failure or breakdown. So breakdown is very important for any organization. So ideally there should be zero breakdown. So when we talk about any equipment, ideally equipment must be 100% available. That's what the expectation of the production guys typically. But there would be some malfunction, some failure would be there. Those are called breakdowns. Okay, so when there is breakdown, it is not good for the company. So when we talk about equipment breakdown, so unplanned downtime due to equipment malfunction or failure. If there is a planned preventive maintenance, it's good, okay, that's a proactive thing. But when there is unplanned downtime, there is breakdown, this is going to be impacting your performance, okay. So this is going to impact machine availability. So availability we have already seen, this is one of the critical factor of overall equipment effectiveness. So when there is breakdown, availability is going to go down, okay. So the examples could be motor failures, electrical faults or mechanical wears. Because of any failures, if the machine is down, machine is not available, this would be called breakdown. And this is one kind of big loss. Move ahead. Second one, setup and adjustment losses. So typically when we start any machine, when we change from model A, let's say I was running model A in molding machine. Now I am changing from model A to model B. So when I am changing the setup from model A to model B, so typically I would be changing the mold also. So that changing the mold, I am talking about injection molding. It's not only injection molding. So any kind of setup change, whether that is injection molding or whether it is stamping or forging, anywhere whenever you are changing the process setup, okay, there would be adjustment. So these setup and adjustment losses are also killing the company, and that is going to impact the availability of machine, and that is going to impact your overall equipment effectiveness. So the impact would be reduces production availability. So availability go down, your OEE is also going to go down, okay. So the description of setup and adjustment losses, time lost during equipment changeover, tool adjustment or recalibration. So in certain cases you might be doing the recalibration once the setup is done. So to confirm the setup, part of the setup only recalibration. So lot many activity goes when you do the setup activities, okay, until unless the first part is okay. So your setup is not complete. So there might be some adjustment, some calibration or recalibration would be going on. So these are the losses. So this is the second loss. Let's talk about the third loss, minor stops and idling. So what exactly is the description? Short stoppages caused by temporary issues that are usually resolved quickly. So there would be some small issues, short issues which could be for a couple of minutes or so, but that is going to impact the efficiency. So this affects the performance efficiency of the machine or equipment or the organization. Ultimately, it is going to impact the organization. For an example, there is misalignment in the sensor and it took 1 minute or 2 minutes. There is material jam. So for removing the material jam, you took 30 seconds, 40 seconds. Or there is operator delay. Operator has gone to washroom and he took some time. Okay, he got a call and he was attending the call. So these kind of small stops, idlings are part of minor stops and idling. So these are also losses, and this is going to impact the performance of the process. Okay, this is the third one. Fourth one is reduce speed. Very important. Your equipment has been designed to run at certain speed. Okay, and if you are running the equipment at lower speed, the reason could be maybe you want to avoid breakdown or quality defects, because the operator or the supervisor might be feeling that if I run the equipment at the highest speed, the product quality might go down. There could be rejection, there could be defects. So to avoid defects, he is running the equipment at reduced speed. So this is also a loss for the organization. This is going to decrease performance efficiency, right? So running machines at lower speeds to avoid either breakdown or quality defects, this is going to be falling under this category, reduced speed, and this is also a big loss. For an example, the equipment is designed to run at 1600 RPM, and you are running at a reduced speed of, let's say, 1400 RPM. Okay. So this is going to be a loss because you are not running the equipment at the design speed, whatever could be the reason. The next one is quality defects and reworks. Of course, we all know time wasted producing defective products. You are producing part. Ideally, the machine or the process should be giving good part only. Whatever is the reason, if the part is not good, the part is getting rejected, or you are doing some rework or repair or something you are doing. So this is basically a loss. So this would be falling under quality defects and rework losses. So this affects quality and increases rework. So in OE we have seen the third element which talks about quality, performance, availability and quality, right? So this is going to impact the quality element of OEE. So examples are incorrect dimensions, poor surface finish or weld failure. There could be different types of defects in different kinds of processes or operations. So whatever are the defects, abnormalities that is going to impact your product quality, unnecessary you are producing defective parts. Sixth loss is reduced yield, startup losses. So what is this loss? So startup losses are losses during startup or ramp up until equipment stabilizes. So when you start the equipment, it might be taking some time to stabilize till you start getting consistent good quality material. So whatever time you are spending, okay, and you might be getting some defective material, that is going to basically impact to your cost of poor quality and your defect rate, and that is going to impact your efficiency, the process efficiency also. So the example could be high scrap rate during initial production run. So when you are setting up the mold on the injection molding line, or setting the dies on stamping machine, or setting the forging machine or any assembly line, so typically there would be some issues coming in, okay, till you get the good quality material and the process stabilizes. So this would be falling under reduced yield and startup losses. The seventh one is logistics and material handling losses. So delays caused by inefficiencies in material supply or movements. This would be falling under this category. So this is going to impact the availability of the materials and performance. So if the material is not available to the process owner, for example, you are doing some assembly and the bought out parts has not come because there is logistic issues or material handling issues. So because of that, the material has not come to the line on time and there is delay in the assembly, or the operator is waiting. So waiting is a loss. It's a kind of muda. We know team wood, 7 types of muda. So one of the muda is waiting. So logistics and material handling losses are going to impact the performance of the process, and availability of the equipment is also going to go down. So this is going to ultimately impact overall equipment effectiveness, right? So waiting for raw material or slow material handling system because of any EOT crane, forklift or anything, okay, this is going to impact your performance. And the next one is energy losses. Energy losses, we know if there is a faulty motor or old motor you are using, that would not be running to the optimal level. There are now better quality of motors available, so you are going to have energy losses. You have faulty the pneumatic or air compressor line, the air line are having problems and there are heavy leakages, and because of that there are energy losses, right? So inefficient energy use or losses in utilities like power, air or water. So it could be power, it could be air, it could be water. So any resources. So that is basically loss of energy. So this increases your operational cost. Okay, operational cost is going to be high and your profitability is going to be low, and affects equipment performance also. So examples are air leakages in pneumatic systems. So there is, let's say there are connections, there are lines, pneumatic pipelines are there, and there are air leakages in different locations. So these are basically big losses. Or inefficient motors. So motor is very old, it is not efficient and there are huge energy consumption. So these are some losses. There could be other losses. For an example, there could be losses because of cutting tool. So there are other losses are also available, but right now we have focused on 8 key losses, which is basically impacting the performance of the organization. So I hope that from this program you must have got some idea about what exactly is TPM in a broader sense, what are the pillars of TPM, and what exactly is zero bad, and how these 8 losses are important for the performance of the organization. So share your comment in the comment section about the video, and if you like the video, don't forget to share the link of the video with your friends and colleagues so that they can also learn something. And if you are new to our channel, then subscribe and click on the bell icon, and don't forget to visit our website www.qualityofindia.com, and you can download our app from Android and iOS store. We have 100 plus online courses available. Lot many courses are free, but there are lot many paid courses available, internationally accredited courses which you can avail at the convenience of your home. So in case of any query, you can contact us. Bye for now. Take care. Jai Hind.